In Episode 7, titled OSI as a Design Tool, Translating Requirements into Network Decisions, we treat the Open Systems Interconnection model as a practical checklist for design clarity rather than a trivia chart you memorize once and forget. When you are reading a requirement, you are really deciding where in the stack a control, a dependency, or a performance constraint lives, and the layers help you avoid skipping steps. The exam uses the stack implicitly because many answer choices differ mainly by which layer they act on and what side effects they create. Using the layers as a checklist also keeps you honest because it forces you to consider not only what should happen, but what must be true for it to happen reliably. The objective is to make the model feel like a tool you reach for automatically when requirements are messy. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. At a high level, each open systems interconnection layer has a role, and you can remember those roles by thinking about how a simple service like a web application actually works end-to-end. The physical layer is about signals and media, which in practical terms means whether a link can carry bits consistently in the first place. The data link layer is about local delivery on a segment, which includes things like switching behavior and the framing that allows devices on the same link to communicate. The network layer is about addressing and routing between networks, which is how traffic finds its way across boundaries rather than staying local. The transport layer is about end-to-end delivery behavior, such as reliability and ordering, which shapes how applications experience the network. The session layer is about establishing and maintaining conversations. The presentation layer is about how data is represented and protected. And the application layer is where services like name resolution and authentication flows appear as dependencies you cannot ignore. Once you have that mental picture, you can map a requirement to the likely layers it affects most, which is the key move that turns the model from theory into design practice. A requirement about connectivity and reachability usually points you toward the network layer, because routing and addressing determine whether endpoints can talk at all. A requirement about performance often points you toward the transport and network layers because latency, loss, and path choice influence throughput and responsiveness. A requirement about user access and identity usually pulls you upward into the application layer because authentication and authorization live in service logic and identity systems. A requirement about confidentiality can touch the presentation layer through encryption, but it also touches the transport and application layers depending on how protection is implemented and enforced. The exam often gives options that all sound plausible, but the best answer is usually the one that targets the layer where the requirement actually lives without creating unnecessary complexity elsewhere. One reason the Open Systems Interconnection Checklist is valuable is that physical and data link issues can mimic higher layer symptoms, which is a classic source of misdiagnosis and wasted effort. Intermittent physical problems can look like application instability because the user experiences timeouts, slow pages, or dropped sessions without seeing the underlying signal loss. Data link problems such as collisions, duplex mismatches, or unstable switching can present as random packet loss, which then triggers transport layer retransmissions that feel like performance problems. When transport behavior compensates for lower layer loss, you might see erratic throughput and latency spikes that tempt people to blame the application or the server. The important lesson is that higher layers often amplify lower layer instability, so the symptom you see is not always the layer at fault. In exam reasoning, this means you should be cautious about answers that jump immediately to application fixes when the scenario hints at link instability or segment-level issues. To keep your design language precise, it helps to know where addressing, routing, and transport choices live in the open systems interconnection model, because these are the building blocks of many network decisions. Addressing and routing are primarily network layer concerns because they determine how packets move across different networks and how reachability is expressed. Transport choices live in the transport layer, and they include behaviors like connection orientation, retransmission, and flow control that shape how reliably data arrives. When a scenario talks about subnets, routes, gateways, or network segmentation boundaries, you are working in the network layer, whether the prompt uses that phrase or not. When a scenario talks about connection reliability, timeouts, or throughput characteristics, you are often in transport territory because delivery behavior is part of the story. Designers make better decisions when they can name the layer, because naming the layer clarifies which levers are available and which are irrelevant. Application layer considerations deserve special attention because modern environments depend on services like domain name system and authentication flows that can fail in ways that look like the network is down. Domain name system is often the first dependency, because users and applications rarely connect by raw Internet Protocol address, and name resolution failures can stop access even when routing is fine. Authentication flows are also application layer heavy because they involve identity providers, token issuance, session lifetimes, and redirects that can break due to configuration, clock skew, or unreachable endpoints. When the scenario includes words like login, single sign-on, directory, certificate, or token, you should immediately think about application dependencies that must be reachable and consistent. These flows also cross boundaries, which means they depend on network and transport stability as well, even though they are expressed as application behavior. In exam questions, answers that fix routing but ignore domain name system or identity dependencies often miss the real requirement, and answers that focus only on application logic without ensuring underlying reachability are equally incomplete. For troubleshooting and validation, divide and conquer works well when you isolate layer groups first rather than trying to inspect every layer at once. A practical grouping is to treat physical and data link as one foundation group, network and transport as the delivery group, and the upper layers as the service group. If the foundation group is unstable, you can waste hours tuning routing or application settings without fixing the real cause. If the delivery group is misconfigured, services will appear unreliable even when the servers are healthy and the applications are correct. If the service group is failing, you might have perfect connectivity but still see errors due to name resolution, authentication, or data formatting problems. The point of isolating groups is not to ignore details, but to reduce the search space so you can reason efficiently. The exam mirrors this approach by providing clues that suggest which group is most likely responsible, and your best answers usually reflect that disciplined isolation. To make this concrete, imagine a short scenario where remote users report that they can reach a company web application intermittently, with login failures that come and go, especially during peak hours. Starting at the application layer, you would consider whether the authentication flow depends on a separate identity service and whether domain name system resolution is consistent for the application and the identity endpoints. At the transport and network layers, you would consider whether timeouts and retransmissions increase during peak, which could indicate congestion, path instability, or overloaded gateways. At the data link and physical layers, you would consider whether a boundary link is saturated or error-prone, causing loss that escalates into higher layer failures. Layer-by-layer reasoning helps you choose an answer that matches the symptom pattern, such as focusing on boundary stability and congestion control rather than rewriting application code. In exam terms, the best option is the one that addresses the layer most consistent with intermittent, load-related behavior while preserving the integrity of the authentication and name resolution dependencies. A common pitfall is blaming applications for network layer faults, because application symptoms are what users see and what dashboards often report first. If packets are being routed incorrectly, if a gateway is flapping, or if segmentation rules are inconsistent, the application will look broken, even if it is behaving perfectly. This is especially true when the transport layer begins retransmitting aggressively because the application experiences delay, timeouts, and partial failures that resemble server overload. In hybrid and cloud environments, network layer issues can also include misrouted traffic across environments, asymmetric paths, or incorrect route propagation, all of which can present as random application errors. The exam often includes distractor answers that recommend application tuning when the scenario contains clear network clues, such as reachability differences by location, sudden onset after a network change, or failures that correlate with specific paths. Staying disciplined with the layer checklist prevents you from taking the bait, because you ask what must be true at each layer before the application can succeed. Security controls rarely live in only one layer, and understanding why they span multiple layers helps you interpret exam answers that bundle controls together. Encryption can be discussed as a presentation layer concept because it protects data representation, but it is often implemented at the transport layer as secure sessions or at the application layer as application-controlled encryption and token protection. Access control can be implemented at the network layer through segmentation and filtering, but it is also implemented at the application layer through authentication and authorization decisions. Logging and monitoring often depend on network visibility, transport metadata, and application context, which means meaningful audit trails span layers by necessity. This multi-layer reality is why secure design answers often include more than one control, and why a single control rarely satisfies a broad security requirement. The key is to ensure the chosen controls align with the requirement and do not conflict with performance, availability, or operational constraints, which the layer checklist helps you evaluate. Memory anchors can make the open systems interconnection model usable under pressure, especially when you pair each layer with a verb that captures its main action. Physical can be linked with carry because it carries bits across a medium in the real world. Data link can be linked with switch because it moves frames within a local segment and enforces local delivery. Network can be linked with route because it decides paths and reachability across networks using addressing. Transport can be linked with deliver because it shapes how data is delivered end-to-end with reliability and flow behavior. Session can be linked with manage, presentation with transform and protect, and application with serve because it serves the actual service dependencies like domain name system and authentication. These verbs are not meant to be perfect definitions. They are meant to be triggers that guide your thinking quickly and consistently. As a review prompt, map one symptom to likely open systems interconnection layers because symptom-to-layer mapping is a skill the exam rewards even when it does not ask for it directly. Consider a symptom like name resolution fails, but connecting by Internet Protocol address works, which points strongly toward application layer domain name system behavior rather than basic routing. Consider a symptom like connections establish, but transfers stall under load, which could involve transport behavior, congestion effects, or loss that increases retransmissions. Consider a symptom like only one building loses connectivity after a change, which suggests a data link or network segmentation issue tied to a local boundary. The point is to practice naming the layer that is most consistent with the symptom, then checking whether lower layers could be the root cause, amplifying upward. When you do this repeatedly, you become faster at eliminating distractor answers that propose fixes at the wrong layer. To close the core with a practice prompt, translate one requirement across layers so you can see how a single sentence implies multiple design decisions. Imagine a requirement such as, remote users must access an internal application securely with minimal latency, and use the layer checklist to interpret it without overcomplicating it. At the application layer, you need consistent domain name system resolution and an authentication flow that works reliably for remote identities. At the network and transport layers, you need stable reachability and a path that manages latency and loss so that interactive sessions do not degrade. At the data link and physical layers, you need the boundary links and segments to be stable enough that the higher layers are not constantly compensating for errors. For security, you need controls that reduce trust across the path, which often means layered enforcement that touches identity and network boundaries rather than relying on a single mechanism. This translation exercise trains you to see requirements as stack-shaped, which is how architects make coherent decisions. In the conclusion of Episode 7, titled OSI as a Design Tool, Translating Requirements into Network Decisions, the big win is using the layers as a checklist that keeps design and troubleshooting grounded. You understand the role of each layer, map requirements to the layers they most affect, and remember that physical and data link issues can mimic higher layer failures in convincing ways. You know where addressing, routing, and transport choices live, and you treat application dependencies like domain name system and authentication flows as first-class requirements rather than afterthoughts. You apply divide and conquer by isolating layer groups, you avoid the trap of blaming applications for network faults, and you recognize that secure controls often span multiple layers simultaneously. Recap the layer checklist and assign yourself one mapping drill by choosing a single requirement and naming the layer impacts from physical up to application, because repeated mapping is what turns the model into a reliable design tool. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.